Have you ever pondered about harnessing the entire energy of a star? Welcome to a journey that will take us beyond the confines of our solar system, into the realm of the extraordinary, the hypothetical, and the utterly mind-boggling. Today we're exploring a concept so grand, so audacious, it defies our earthly notions of scale and engineering. We're talking about the Dyson Sphere. A Dyson Sphere, as theoretical as it may be, is a concept that's captured the imaginations of scientists, writers, and dreamers alike. It's a megastructure, a colossal artifact of engineering, designed to encapsulate a star entirely, capturing every joule of energy it emits. Yes, that's right, every single joule. So, where did this concept originate? The idea of the Dyson Sphere traces its roots back to the imaginative mind of British philosopher and science fiction author Olaf Stapledon. In his 1937 novel, Star Maker, Stapledon envisioned civilizations harnessing the energy of stars using what he called every solar photon. This concept was later picked up and expanded upon by the renowned physicist Freeman Dyson in the 1960s. Dyson, intrigued by Stapledon's idea, proposed the concept of a shell of solar collectors around the sun, a structure that could harness the full power output of a star. He argued that this would be the logical next step for any advanced civilization seeking to meet its energy needs. This hypothetical megastructure, he suggested, would be the hallmark of a civilization that has reached the pinnacle of technological advancement, a civilization that has mastered the resources of its own star. And so, the concept of the Dyson Sphere was born, named in honor of the man who brought it into the scientific mainstream. It remains a beacon of what could be, a testament to the limitless potential of human ingenuity and technological prowess. Imagine, a civilization advanced enough to construct such a megastructure. So, how could one go about building a Dyson Sphere? This is where we delve into the realm of the theoretical and the fantastical. To understand the making of a Dyson Sphere, we must first grasp the scale of this project. We're talking about a structure with the circumference of a star's orbit, a celestial megastructure that would completely encompass a star. The size would be so enormous that it could contain all the planets in our solar system with room to spare. The construction process would be extraordinary. First, we would need to gather the immense amount of material required. One theory suggests dismantling a planet, like Jupiter or even our Earth, to obtain the raw resources. But even that might not be enough. We might need to harvest materials from multiple planets, asteroids, and other celestial bodies. Next, we would need to manufacture the sphere itself. This would require technology far beyond our current capabilities. Imagine machines that could operate in the harsh conditions of space, capable of withstanding intense heat, extreme cold, and deadly radiation. These machines would need to be self-replicating, able to repair themselves, and capable of working autonomously over incredibly long timescales. The sphere would need to be assembled piece by piece in space around the star. Each piece would be a solar panel, collecting and transmitting the star's energy back to where it's needed. The challenge would be to construct and position these panels so they can withstand the star's gravitational pull and radiation, while still capturing as much energy as possible. And let's not forget the challenge of living and working in space for extended periods. We would need to develop sustainable life support systems, advanced propulsion technologies, and a myriad of other advancements to support a workforce in the harsh environment of space. The making of a Dyson Sphere is a task of such monumental proportion that it pushes the boundaries of our imagination. It requires resources beyond comprehension, technologies yet to be invented, and a resolve that is, quite literally, out of this world. An endeavor that truly boggles the mind, isn't it? A Dyson Sphere is not just about energy, it also implies a new way of living. Imagine, if you will, a civilization advanced enough to construct such a colossal structure, harnessing the power of an entire star. But what about the inhabitants of this superstructure? How would life unfold under the light of a captive star? Let's delve into the heart of a Dyson Sphere. The internal surface, vast beyond comprehension, could potentially be terraformed to support life as we know it. Picture continents and oceans, forests and cities all sprawling across the inner curve of a sphere. A world within a world, lit by a star held in its heart. But how would day and night work inside a Dyson Sphere? This is where things get really interesting. Unlike our planet, where day and night are a result of its rotation, a Dyson Sphere would be stationary relative to its star. This means we would have to devise a new way to simulate the comforting rhythm of day and night, perhaps by modulating the output of the star or using some form of gigantic shades. Indeed, The inhabitants would need to rethink their concept of time. In such a society, the notion of up and down would also be redefined. Instead of looking up to see the sky, inhabitants would look inward, towards the core where the star resides. Look outward, and you'd see the rest of the sphere stretching up and around you, a horizon curving upward in a surreal twist of perspective. And what about the weather? With no natural wind patterns or ocean currents, weather systems would need to be artificially controlled. A challenge, certainly, but not insurmountable for a civilization capable of constructing a Dyson sphere. Living inside a Dyson sphere would be a marvel of technological prowess, and a testament to the indomitable spirit of exploration and innovation. It's a concept that challenges our understanding of what a home could be, a life within a star, a concept straight out of science fiction. The creation of a Dyson sphere would not just be a technological marvel but would have far-reaching implications. Imagine, if you will, a man-made structure so enormous it completely encapsulates a star, harnessing every iota of its energy. This is the promise of a Dyson sphere. But what would be the repercussions of such an unprecedented leap in technology? First and foremost, the successful construction of a Dyson sphere would, quite literally, propel us to the stars. With the power of the sun at our fingertips, interstellar travel would no longer be a dream but a reality. The sheer amount of energy harnessed would be enough to fuel spaceships capable of journeying to the furthest reaches of our galaxy and beyond. We would become explorers in the truest sense, charting the unknown expanses of the universe. However, such a monumental achievement would not come without its social and political impacts. Imagine a world where energy is no longer a scarce resource, where the sun's boundless power is harnessed for the benefit of all. This could drastically alter societal structures, potentially leveling economic disparities and reshaping the world order. But it also raises questions about power and control. Who would take the helm of such a potent resource? How would we ensure that this power isn't wielded for nefarious purposes? These are questions that we, as a society, would need to grapple with. Moreover, the successful construction of a Dyson sphere would signify our ascent to a Type II civilization on the Kardashev scale, a system used to measure a civilization's level of technological advancement. We would no longer be bound by the confines of our planet or even our solar system. We would have the power to shape our destiny, to steer the course of human evolution. In conclusion, the Dyson sphere is not just a fascinating concept, but a beacon of what we could become, a symbol of our potential to transcend our earthly limitations. The Dyson sphere, a symbol of a civilization's ascendancy to the stars. Are we alone in the universe, or could there be civilizations out there that have already built their own Dyson spheres? This question, posed by many a curious mind, has led to serious efforts in the scientific community to detect these hypothetical megastructures. The search for Dyson spheres is akin to a cosmic treasure hunt. It is not only about finding these colossal structures but also about uncovering indications of advanced civilizations. But how do we go about finding something so vast, yet so elusive? The answer lies in the very nature of a Dyson sphere. Remember, the primary function of a Dyson sphere is to capture and utilize the energy of a star. Consequently, a functioning Dyson sphere would emit a significant amount of waste heat in the form of infrared radiation. This is where we direct our gaze. Our search for Dyson spheres has led us to the infrared spectrum. Observatories across the world, equipped with infrared telescopes, are diligently scanning the cosmos for unusual heat signatures. These could potentially be the telltale signs of a Dyson sphere in action. Imagine a star's light, dimmed not by natural processes but by an artificial shell, its energy being harnessed by an advanced civilization. This search is not just about finding Dyson spheres, it's about finding answers. It's about understanding our place in the universe. It's about contemplating our own future. Could we one day harness the power of our sun in such a way? Could we build a Dyson sphere of our own? As we peer into the cosmos, we might just find evidence of these cosmic marvels. Or who knows, we might even become the builders of the first Dyson sphere ourselves.